Our class today that we're going to be focusing on is Math 8. The topic, Lesson 17, the converse of the Pythagorean Theorem. If you have not watched Lesson 16 yet, this is where I first introduce what the Pythagorean Theorem is, one of my most favorite formulas, and how it can be used both in math and in real-life situations. Today we're extending upon that knowledge, so if you haven't watched that video, please go back. I'll link it to this, and make sure that you watch it before starting on this lesson. Once again, this is for Math 8, and this is Lesson 17, the converse of the Pythagorean Theorem. To begin with, I'm going to go ahead and start by going over our essential question. I'll be reading it to you, and here we go. So our essential question, or EQ for today, is how do I determine if the side lengths create a right triangle? Now, our Pythagorean theorem that we are going to be working with works with a right triangle. So today, you are going to be given 3 different side lengths, well, 2 side lengths and 1 hypotenuse, and you're going to need to put those into the formula to ultimately determine if those are a right triangle, if those lengths create a right triangle. So here we go. The converse of the Pythagorean theorem. The converse basically states that if a squared plus b squared equals c squared, then the triangle is a right triangle. This is a way for us to prove, without being given this right angle, if we actually have a right triangle. So, keeping that in mind, here we go. So the converse of the Pythagorean theorem makes it possible to determine if a right triangle is a right triangle when the lengths of the sides are known. What this means is that if I'm given the length of A, the length of B, and the length of C, I can plug those into my formula to determine if the numbers I have actually create a right triangle. The next piece that we're going to talk about is what's called a Pythagorean triple. A Pythagorean triple is a set of 3 positive integers being numbers, that we get a squared plus b squared equals c squared. So, again, a Pythagorean triple is a set of 3 positive integers so that a squared plus b squared is equals to c squared. An example that we have is this problem here. A triangle has side lengths of 3.5, 12.5, and 12. Determine if this is a right triangle. Now, the first thing we're going to need to do is identify which one of these is our hypotenuse. The hypotenuse is always the longest leg of the triangle. So for this particular problem, again, the hypotenuse is always the largest number. So we're going to begin by identifying that 12.5 is our hypotenuse. Okay. Our second step is we are now going to label the other 2 integers, 3.5 and 12, as the legs. So those are the A and the B of our formula. Next, we're going to write the Pythagorean theorem, and we're going to substitute those values. So here, my 3.5 was A, and the 12 was B. This 12.5 is C. So I'm going to write the Pythagorean theorem, and I'm going to substitute in those values. So A was 3.5, so I'm going to go 3.5 squared, plus 12, which was my B, so 12 squared, is equals to 12.5 squared. That's my C. Now I'm going to find out what 3.5 is. 3.5 squared. Let me get my calculator. Here we go. 3.5 squared is 12.25. Plus 12 squared, which is 144. And that needs to equal 12.5 squared. And 12.5 squared is 156.25. Now, I'm going to add the 12.5 and the 144 together. 12.25 and the 144. And when I do that, I do happen to get 156.25. Now, I kind of jumped ahead of myself a little bit, and in the notes, it says simplify by squaring. That's where we're going to go ahead and get the 12.25 plus 144 is equals to 156.25. Okay. And then our last step was to check and see if one side of the equation matches the other. And in this case, 12.25 plus 144 do happen to equal 156.25. Now, because these integers here, these numbers, equal each other, therefore we're going to state if these integers create a right triangle. And in this case, we can state, yes, they create a right, and I'm going to use RT for right, and then the symbol for triangle. So yes, they create a right triangle. That's our lesson. So today, what we're going to be taking a look at is this exact piece. We're going to be utilizing that Pythagorean theorem to help us identify if we have a right triangle and if a set of numbers is a Pythagorean triple. So here we go. This is your assignment today. It's Math 8, Lesson 17, the topic, Converse of the Pythagorean Theorem. As this is 2 pages, please make sure that you write your first and last name on both pages. It makes the scanning for our IAs a lot easier. So I'm going to write my name. I'm going to put the class period. You guys have me for period 1. And then today's date is 4/16/2020. So, starting out here, I'm going to first begin by determining which of these numbers is my hypotenuse. I'm going to go ahead and start out on number 4. Okay. For number 4, I have 4.3, I have 8.3, and I have 6.9. Once again, I'm going to identify what is my hypotenuse first, and that hypotenuse is always the largest number. So I'm going to put a C underneath the 8.3. Now, I can use either number, either the 4.3 or the 6.9 for my A. I'm just going to put the A under the 4.3, and I'm going to put the B under the 6.9. Now, using these integers, I'm going to go ahead and put these numbers into my formula. Once again, that formula is A squared plus B squared equals C squared. So I'm going to go 4.3 squared plus 6.9 squared equals 8.3 squared. Now, 4.3 squared is 18.49. 6.9 squared is 47.61. And 8.3 squared is 68.89. Now, I'm going to combine these two numbers here together. So I'm going to go 18.49 plus 47.61. That's going to give us 66.1 equals 68.89. Now, because these two numbers do not equal each other, we're going to put a line through our equals. That means does not equal. And we're going to write no, not a right triangle. Okay. So you're going to do that on every problem for numbers 1 through 6. Now, once again, here for numbers 7 through 12, you are once again being given 3 different integers. Now, all of these happen to be labeled in order, from smallest to greatest. So the last number is always going to be your hypotenuse. So I'm going to go ahead and use, let's do number 12. Now, unfortunately, my calculator at home does not have a function of using fractions. So I'm going to turn each one of these into a decimal. Now, 3/5, and I'm going to zoom in here. And focus. All right, so 3/5 as a decimal is 0.6. So I'm going to use that function. 4/5 is 0.8, and then 1 is just 1. So for me, I'm going to have to use those decimals instead of the fractions, just because my calculator at home does not have that fractional component. If yours does not either, you can also go ahead and put these in decimal form. Just make sure that you're using the correct decimal form. Now, I'm going to plug this in. So I'm going to go 0.6 squared plus 0.8 squared equals 1 squared. Now, 1 squared is just 1. So I'm going to put 1 is equals to 0.6 times 0.6, that's 0.36. And then 0.8 times 0.8, that's going to be 0.64. Now, adding 0.36 plus 0.64, we get 1. So we get 1 equals 1. Now, ultimately, our directions were to state if the set of numbers is a Pythagorean triple, and in this case, we'd write yes, and we would circle it. That is our final answer on number 12. Now, looking at number 13 and number 14, they are multi-step problems, so please make sure when you take a look at number 13 and 14 that you take a look at the instructions. Now, at any point in this lesson or this assignment, you have any questions, please leave me a comment. Please send me a message. I'm here to help any way I possibly can. Thank you so very much for watching. This has been Mrs. Ross Does Math.